Hi again, everyone, and welcome to our second talk of OmniTestingConf. Our speaker for this session is Paul Grizzafi, who is a principal test automation architect. His talk will introduce you to some classic test automation myths, how they've been debunked, and the times when a myth is not a myth if applied to a specific context. Of course, during the talk, you can ask questions through the Ask a Question button on the right side panel. And afterwards, we'll have a 10-minute Q&A where Paul will answer all of your questions. And with that, I'll pass it over to our speaker. Paul, over to you.
Hello, everyone, and thank you for spending some time with me today. We are going to talk about the myths about automation. And we're going to bust them, and then we're going to unbust them. So quickly, just a little bit about me. My name is Paul Grizzaffi. I am a principal automation architect at Cognizant Softvision. We were purchased by Cognizant Softvision. I used to be at Magenic, and now, so if you see me from before, at Magenic, I'm still sort of at Magenic, but with now Cognizant Softvision. And my career has been primarily focused on automation. I did a little small stint over at a director of QA and QE organization, and it was cool. But the automation is still my focus and my passion, really. So I am an industry advisor to both the software test professionals and the University of Texas at Dallas. And if you want to talk to me about running wild versus Halloween versus gamma ray, I'm happy to talk to you about that. Ping me here. If you want to talk to me outside of this particular forum, here's my information. You can get me there, and that link at the bottom is my it's where I blog, and my mostly cogent thoughts go there. So I'm mostly a jump kind of in kind of guy, so let's go and jump in. What is this whole thing about myths? So many of us think about the things that we do and the things that we know, and some of them are myths. They're not actually true, or they're true in some weird sort of circumstances, but mostly they're myths. They are things that we are told, things that we believe, things that we learned out of context and out of sort of what works for you in your bigger world. So let's talk about those myths and why they're myths about the myths. So the first myth, we should be using record and playback. Or, in the bigger picture, we're going to do codeless or we're going to do scriptless. As the bullet says here, codeless or scriptless. Because programming is hard and programming takes time, and it does. Not going to lie to you, it takes time. You have to learn it, you have to go for it. And what we really want to do here is we want to accelerate test script creation, because the faster we can accelerate those test scripts, the faster we get to testing, right? And anyone can do it. We can get anyone who can run a mouse or the application under test that we're using, and they can run this and they can do it. Busted. So this has been busted a very long time ago, because in most circumstances, record and playback is invaluable. Or at the very least, it's not something you want to build a large scale enterprise level automation initiative based on, because the generated code is brittle, which means it's going to break every time you have a small tweak in your UI. And when I say UI here, I mean specifically the GUI, the web browser, the web page, the thick client, whatever it is. You tweak some stuff in there depending on how the code was generated and recorded for the record and playback. You may have to re-record, because generating code is hard to modify. And sometimes it's hard to maintain. The whole thing can be difficult, and some things are expensive to re-record. But let's unbust that myth for a second, shall we? because record and playback or codeless or scriptless can absolutely 100% be valuable. Yes, I know I'm the automation dude. I should not be espousing the record and playback, but there's value there. I'm about value. I'm about let's make the most of what we're doing, but you have to use it appropriately. So what we have to do is we have to learn how to interact with controls and elements. And record and playback can absolutely help us with the difficult ones that we don't really know how to control or to interact with, simply because the aspect of what we're talking about can be a little difficult. But record and playback can absolutely be good for disposable automation. What do you mean disposable automation? I have a different talk, and it's one that I give to a university lecture sometimes, where I say, hey, is it ever valuable to automate something that you're going to run once? And I usually get some hands and some weird looks and some people that say, please get me out of this class. Um, so things that we're going to throw away that we don't have to maintain, record and playback can be awesome for that, because we get it done quickly, we execute the task that we want, and we don't have to maintain it. So therefore, we don't have to worry about the brittleness. We don't have to worry about the fact that some of these things can have to be re-recorded, or that the UI is going to change out from under us. No, we executed some tasks and then we're good. The sort of flip side to that is, for those activities, those user interfaces, whether they're going to be programmatic interfaces or GUI interfaces, those that aren't going to change at all, or they're not going to change frequently, record and playback can be awesome for that as well, but for the same reason, because we don't have to maintain those. We don't have to worry about something's changed. Let's go change the script. Let's re-record. Let's just keep reproducing the same thing we did before, and it's going to work for us in general, because we didn't have to change the underlying implementation. So another myth, that the tech is the hard part. The implementation, the programming, the typing of the keys, that's the hard part. Because programming's hard. And in some cases, in some facilities, programming is hard, depending on what it is you have to do. And the tools are confusing, and they require training, and that is absolutely true. There are some tools out there that are difficult to use, especially when you get into the open source area. In the open source area, a lot of the tools work very, very well, but the documentation on how to use them and how to maintain what you've created going forward, that documentation is very sparse. It's difficult to find that, and you're kind of on your own to fool with that. But if you're going to go with a vendor supplied tool, they're expensive. Yep, you have to lay out a bunch of cash out of your pocket up front. And then if I have multiple operating systems and multiple hardware pieces, man, that's going to be difficult to just get a tool or even like two tools to do all this work for us. So it's like super hard. So that this whole tech thing is difficult because I don't know what to pick. I don't know how to go forward. Busted. This is another myth we're going to bust. Because the programming is a learnable skill. And sometimes it's the hardest part, but sometimes it's not. And in fact, most of the time, it's not the hardest part. Tool training, language training, those are things that are available, sometimes for free. If you go to Test Automation University, based off of out of Apple Tools, Angie Jones, hey Angie, if you go there, there's a lot of high-end technical training for free in the automation space. So Not all the training's there, not the in-depth training sometimes, but the intro level and sometimes the advanced level stuff's there for you as well. But everything does have a cost. Either you're going to have this cost up front or you're going to sort of pay it along the way. What does an upfront cost look like? An upfront cost looks like you paying a vendor for tool X. Hey, I have tool X. I'm going to pay you this money. I'm going to get the tool and I'm going to get some training and support or all these other things. Or I'm not going to do that. I'm going to go the open source route. Open source is free. Free as in it's free to license, it's free to use, but it's not free just from a zero effort standpoint. There's still some learning, some training, some things you have to do there. You may have to pay for that. You may have to go to somewhere that's free, like Test Automation University, something that's relatively low cost, like Pluralsight or Udemy, and get some training there. But it's not a drop in and everybody understands it. You have to learn. And changing culture to include testability and automation ability, that's the hard part. In general, in the big giant picture of things, that's the hard part. Especially if we're talking about an application that we want to test or we want to automate against that's been around a while, that's been around more than 10 years, and they exist. More than 20 years, they also exist. They weren't implemented with testability in mind, and they certainly weren't implemented with automatability in mind. So when it comes to changing the culture around, let's make some changes in the product to make it more testable or to make it more automatable, that's hard. It's very hard because it introduces risk into the application that's been working pretty well along the way. So we have to balance that risk with what the reward is. And the reward potentially is more testability. So you find errors earlier. You find more errors, things you wouldn't have found outside of that. And if you're going to make it more automatable, potentially you get your feedback faster. But let's bust that one too, or unbust it. So tech's hard. There's nothing simple about the technology of what we're talking about. A lot of times we'll get the sort of the development leadership or the testing leadership that says, cool, we're now agile, we're now DevOps, we're now whatever flavor of the day is. So automate, go forth and automate. That's awesome to go forth and automate, but it's not free. There's training, there's understanding, and the more that you have, the lack of people that have those sorts of deep skills, you're going to struggle, and that's okay too. If you struggle and you're tolerant of failure, then you can iterate, evolve, and move on to the next one. But if you're not tolerant of failure, if your schedule, your business, whatever, cannot digest iterative learning and failures along the way, you're going to have to bring in some expertise. You're going to have to hire it in. You're going to have to rent it in, like bring in somebody like myself, or you're going to have to grow it. And if you grow it, then you have to be tolerant for that because programming's learnable, but you need experience or tolerance. And there's training out there. There really is. Like I said, there's the Test Automation University. There are other places that you can get training that is free or very low cost, but there is a cost. At the very least, there's an effort cost, right? An opportunity cost. If your people are spending time training up on something, then they're not doing something else. Or it has an actual dollar outlay cost. And automation is helpful for tool selection. If you're in the world where you are just ramping up your automation initiative, either because you haven't been automating before, you're going to automate now, or you're completely in greenfield and we're building a new product, so we're going to build this whole ecosystem around it. Having people who are experienced in automation and have that level of expertise around what automation is and is not and what it does and does not do is very helpful. And again, you could bring that in, you can pay for it, right? You can buy that expertise, or you can grow it, or you can rent it from consultants. Ooh, and this is one of my favorite myths. Automation comes from test cases, because the first thing you always want to do is you want to automate your smoke suite. And then you want to automate your regression suite, because we want to automate all the manual things. What we want to do is we want to take all of this observably high effort work from humans, let machines do that ostensibly to let the humans do something that's more appropriate to humans. Busted. That is not always where we want to spend our time and therefore our cash. Because automation really is so much more than computer replaces person. What we need to think about automation as is the force multiplier, something that takes what we're doing and makes it bigger, stronger, faster, sort of like the whole $6 million man thing, right? Where we say better, stronger, faster. That's what we want automation to help us do. So we really should think less about automation and think more about assistance. Thinking about what our testers, our QA people, our QE people, however they're designated and whatever their job role is, how do we take them and make them more effective or more efficient? Because assistance is what we want the computers to do to help the testers do their job, be more effective, more efficient. So we think more about what I've been calling automation assist and what sort of the Ministry of Testing world, Richard Bradshaw and Mark Wittering have been talking about automation and testing. We want to focus on those things that testers do, that they spend their time on, that they spend most of their effort on, a lot of their effort on, like, say, data creation and data management. And let's focus the automation on that. Oh, wait a minute, we're going to unbust that one too. Because test case-based automation can provide value. I do a whole separate talk about non-traditional automation, but I make a core point of saying traditional test case-based automation can provide value. And in all the endeavors I've been in so far, this type of automation has provided value. However, it's only been a sliver of the value. Sometimes it's a big sliver, but sometimes it's a smaller sliver. So what we want to do is we want to focus on the value. Because like automation execution of smoke suites on each deploy, high value, but it may not be the first thing you want to do. Perhaps the first thing you want to do is help automate, say, data creation or data integration or data upload, or things that help the testers spend less time doing things that computers are very good at. Automation can't do it all, but it can provide value, and the value is a core part of what we're talking about here. Thinking about what you do as a tester, what you do as a testing leader, and what your team does, let's focus on those things where they're spending their time that machines, computers, automation can help them be valuable. You have to be responsible, and you have to be judicious in your decisions, right? You have to decide, I have X amount of hours, I have X amount of people, and I need to get this testing done. I have to execute certain processes. I have to execute certain tasks. I have to report certain amounts of information. Anything that you can do from a automation standpoint, a programmatic standpoint, that can help you make that job more effective or more efficient is something you absolutely should look at. So if you step back from the fact that automation is test cases, which it is not, automation is helping the users, the humans, do their job more effectively and more efficiently. You get more opportunities to leverage what computers do well, to take that away from the humans so that the humans can do what the humans do well. And of course, automation is going to solve all of your testing problems. You know why? Because testing is a bottleneck to delivery. So automation is going to fix that. Why? Because automation is going to go faster. And testing is expensive, and automation is going to fix that too. Why? Well, automation is going to do what a whole crap ton of people just did for you. And we have too many bugs. Automation is going to sort that out too for you, right? Right? So we're going to go faster. The whole idea of automation is faster and cheaper, but busted. That is generally not the right way to approach automation, because testability can alleviate a lot of these bottlenecks. Oh, wait a minute. If I added these few things to the product that I'm testing, then I can test a lot more effectively. I can check a lot more things, and I don't need automation for that. Oh, wait, we have too many bugs making it out to the production. Automation usually doesn't find bugs. Now, I say usually because there are mechanisms you can use for automation, and they can help you identify risks and things that aren't working really well. Primarily, if you go and research something called high volume automated testing, that will help you out a lot. But other than that, I'm a greedy guy. When I come to a team and we talk about, is automation providing value, I'm very greedy. So if my team, my people, or myself, if I'm writing a script or they're writing a script and they find a problem in the application while they're writing the script, I call that found by automation. You know why? Because if we weren't doing the automation, we wouldn't have found it, or we wouldn't have found it at this point. So absolutely, automation can find bugs, but generally, the way we use it, it does not. And automation is expensive. Somebody has to write those scripts, and somebody has to maintain them. Maintenance is not free. Automation is not a one and done. No matter what tool, what approach, what process, which implementation you use, it's not free. At the very least, maintenance has to happen. And sometimes maintenance is high and sometimes maintenance is low, but somebody has to write them and maintain them. Oh, but wait a minute. Are you telling me that perhaps test case-based automation is okay? And that testing can solve some problems? Absolutely. Test case automation, or any automation really, can help you go faster. At the most rudimentary level, we can go concurrent. Concurrency meaning in parallel. We can run X number of test cases in parallel. Hey, we have 100 test cases or test scripts in sequence. It takes an hour to run, but if we run 5 concurrently, the whole thing takes 20 minutes to run. Awesome, cool. And it can help you increase your coverage. Evaluate opportunity cost, though, because if you're going to spend time doing automation, you're not going to be spending your time doing something else, like other testing, like data management, like whatever. And that's okay. It is okay to spend that time doing automation to increase your coverage or to do anything else for you. However, there's something else you're not doing, so you have to weigh the balance of the risk and the reward and the cost and the value. And automation can absolutely help you identify issues faster, where they might maybe be cheaper to address. And we'll talk about the cheaper to address thing in just a second, because that is a myth of itself and on its own. So wrapping up here, 100% automation is the goal, because you know what? What we want to do is we want to get testers absolutely automating everything. And then maybe we don't need them. Or maybe they're doing exploratory testing, which we can kind of agree that automation isn't really the thing, right? Because automation's faster than testers. And this famous tech company, they don't have testers. They automate all of it. Busted. And this is the other one of my favorite ones to bust. Because automation is about using technology to help testers. It's not about replacing testers. If you want to replace testers, well, they better not be doing anything that's very interesting. Because automation is not always faster. I've actually developed automation to do things that humans have done, and the humans could do them faster because humans can do things. We can all look at things and say, this is good, this is not, this is good, this is not. But from an automation standpoint, we have to check. We have to programmatically check all those things that we as humans, as testers, as just people, look and go, this is it, this is not. Those all have to be programmed in, and sometimes they take a while. And automation might not be as valuable in some cases. I worked at a company one time where we did a thing that was a deal of the day. And the deal of the day was, hey, we're going to pop up this little thing. You go to the website, it pops up and says, Cole, here's what the deal of the day is. But they popped it up as a GIF. And there was nothing we could really intelligently and valuably interrogate from an automation standpoint. We could test that the pop-up came up, but outside of that, a human was going to have to look at the image and then click on it and determine whether it went to the right place anyway. So the right way to do that was not automated, and just let the humans test it, because that's what humans are good at. And I do this a lot in the conference talks I give is hey, Google, Facebook, Amazon, whatever does process XYZ. Who here works for any of those companies? Raise your hand. And invariably, nobody raises their hand. And that's okay. Not all of us can work for those companies, right? So famous tech company has deep pockets, and your company, your team, probably does not. So when we talk about this whole notion of 100% automation, it's probably not feasible for most of us. And 100% automation is, from a computational and understanding standpoint, it really is impossible. We can't understand all the things that our software does, because these days the way our software works with all the interconnected processes, some of which you don't control. Hey, does your e-commerce app talk to bank X or talk to PayPal or whatever? At the point that it talks to those external entities that we don't control, we can't really test effectively at that level, right? Ooh, but let's unbust some of those things too. So 100% may be feasible for some code areas, particularly APIs. If what we're talking about is a subset of our system, or a system that only exists in APIs, the 100% automation becomes more feasible. You still have to be able to enumerate all of the interesting cases, which most of us can't, because it's we're flawed, right? So humans are flawed. We're flawed beings. So we can only do what we can do. But approaching that, so if we draw that on that sort of approaching curve, approaching 100% automation for APIs is feasible in certain circumstances. And we might, maybe, be able to automate 100% of our critical flows. Now, what's a critical flow? Well, I want to buy with a credit card. Cool. Let's automate that. Well, I want to buy with PayPal. Cool. Let's automate that. Well, I want to be able to automate with ACH from my bank. Cool. Let's automate that. But what about when one of those transactions fails? Well, we can automate that too. Well, what about when I typed in a wrong number? So it didn't really fail, but it didn't actually initiate. We can automate that too. So see, very quickly, just like in 2 minutes or 2 seconds, here I've come up with some circumstances that is difficult to do. But if we can enumerate them, we can enumerate most of our critical flows and therefore automate them. But, and this is a very, very big but, if what we want to do is be able to deploy on each developer check-in, as in developer checks in, goes through this continuous deployment, continuous integration, grind, check, roll out to production, we can really only do that if we have a low cost of change and a low cost of failure, because there's some things computers can't check yet. We have to be able to have human eyes on some things. What happens if the color scheme got messed up and everything is pink? Is your automation going to check that? Well, if you have visual automation baked in, maybe, but your typical day-to-day automation is not going to pick that up. Hey, can I buy something? Did I click all the buttons? Yes, absolutely I did. And everything's pink. So not everything's going to be able to be caught that way. So we need to have this low cost of change and low cost of failure so that when we do identify these issues out in production, we can change it quickly. And nobody's going to lose a kidney, right? We're not on the kidney schedule, the kidney replacement schedule automation deck, right? We're in a place where it's a low cost. And hey, you want to replace the testers? Absolutely. Go ahead and replace those testers. But hopefully your testers have only been performing tasks that are scriptable and deterministic, which a lot of the testing we do is not. Sometimes this comes back, sometimes this other thing comes back, and it might be good in both ways. Oh, wait. We can automate that too. But if what we're doing is having testers that all they do is, without exaggeration, click, 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 did this come back? Click, 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 did that come back? Those people may be replaceable. But most humans are not that way. They may be following a script. They may have been told to follow a script. However, if they see something that's weird, they're probably at least going to ask somebody and say, is this supposed to work this way? Computers are not at the level to be able to do that in a general, broad sense yet. And the other place you can replace testers is if you have leadership that doesn't understand testing. Now, let me caution you. Going to talk to leadership, development leadership, business leadership about testing techniques and pairwise and high volume automation testing and randomization and testing, they're going to look at you like you have 7 heads. They don't care about any of that. However, if you talk to them about risk, if you talk to them about opportunity cost, as in, well, if we're doing this thing here with automation, or we're doing this testing thing, or whatever it is, there are these other things we're not getting to, or we're getting to them later. Therefore, there's a cost associated with that from we're not getting revenue for something we haven't released, or we're still sinking cost into something we haven't fixed. They understand that. Now, the inspiration for this talk is something that came from the Leprechauns of Software Engineering and I'm pretty sure I butcher his name every time, but I'm believe it's pronounced Laurent Bossavit. Read this book. The whole book, the way I've read it, is many of the things that we've learned, like, say, it's cheaper to fix a bug in dev than in QA, than in prod. There may be some specific contexts where those are true and other contexts where they are not. And what Laurent does in the book is he takes those myths, those leprechauns, as you will, and he dispels them from a here are the facts standpoint. And it's great to take those in a cold engineering and mathematical standpoint and then say, how does this apply what I'm working on now? And I cannot recommend this book highly enough. So this is what sort of brought me to develop the talk in the first place. Buy the book, read the book. It's an ebook. It's not expensive. So I don't have a whole lot of wrap up, but I am going to punt over to the live session to say, give me your questions. However, if you want to contact me outside of this forum, here's my info.